Okay, so now we've thought about how this relationship should work, and the question is can we formalize that a little bit more? And the way that we're going to formalize that is by borrowing some techniques from statistics. And the technique that we're going to borrow is the calculation of what's called the variance and the standard deviation of return, right? So if return is the average return, it's the slope of the line in those graphs. Variation is the amount of squiggle in those graphs. And of course, I really wish I could actually remember the right term for that, but I'm blanking right now. So it's just the amount that that line fluctuates around its average. And that's called the variance, right? So a stock with a higher variance has a higher risk because the variance measures the spread of total possible outcomes, right? This is sometimes called volatility, right? Volatility is the spread of potential outcomes in the future, right? So the greater the volatility, the greater the uncertainty, and that's why we use variance and standard deviation to measure risk, right? So again, risk is both above the average and below the average. It's not just downside, it's the spread of possible outcomes. Okay. Now, one way to calculate variance from a sample, right, so a set of observations, a set of data, is something called the historical variance, and that is the sum of squared deviations from the mean. That deviation from the mean is above and below the line, right, above and below the average. And the standard deviation is the square root of the variance. Okay, so these are the two ways that we measure the risk. These are the two ways that we measure the fluctuation around the average, and that's how we understand risk. Okay, so if we look at a sample, this just means a small sampling of potential returns for an individual stock. So we could say, look in this far left-hand column, we got 4 years of returns for a stock. So 15% in the first year, 9% in the second year, 6% in the third year, 12% in the fourth year. All right, so this is our stock. It's gone sort of fluctuated up and down. We want to know what the average return is, because that's what we expect to happen. So that's 10%. So we just took the simple average here, added the four averages together, divided by 4. 10.5% is our average. The deviation from the mean, which is another word for the average, is in that third column. So this is subtract the average return from the actual return. All right, so we can see that there has been some fluctuation. The squared deviation is taking the deviation and squaring it, so multiplying it by itself. And we then divide by the number of observations. That gives us the variance, right? So 0.0015. Now, we don't interpret the variance because it's not in a way that's easily interpretable for us. But if we take the square root of the variance, we get the standard deviation, and the standard deviation is in percentage terms. So these two things help us characterize a stock. And we're going to talk about this a lot more in the next chapter. We're going to do the examples. We're going to do lots of the math. So I don't want to get too bogged down in the math here. And so if you just bear with me through here until chapter 13, we'll get into the nitty gritty and we'll do a lot of variance standard deviation examples. Okay, so don't worry about the math so much quite yet. But the average return and the standard deviation characterizes the risk-return relationship for this stock. So we expect a return of 10%, but the standard deviation of about 4%, 3.8%, tells us how much we should expect the return to fluctuate in any given year. Okay? And that's how we really think about risk and return. Okay? Now I'm going to skip these next two slides because they're also in the following chapter, and I think it's a more appropriate way to cover these next two slides in the following chapter. So we'll wait there. But if we continue on with our discussion of the 5 or 6 different portfolios, the different types, right? So large stocks, small stocks, long-term bonds. We can see that we can see the average return and the standard deviation for all these different portfolios here. So the average return for large stocks is about 12%. The average return for small stocks is about 16.7%. the risk, the standard deviation, and the fluctuation in return for large stocks is 20%, while for small stocks it's 32%, right? So the way we think about that is the standard deviation tells us how much we should expect the actual return to vary in any given year. So that's huge. I mean, the fluctuation of 32% around the average is enormous. Okay, whereas for long-term bonds, the risk is quite small comparatively, 8%. For long-term government bonds, it's 9%. For short-term treasury bonds, it's 3%. The risk is relatively small comparatively. Right? And so what we see in that final column, the frequency distribution, this is the spread of returns. So the spread of whether we made money or lost money in any given year. And you can see that that's sort of a visual description of risk. Right, and in the same way that in the graph, the jumpiness of the line was a visual description of the variance. This is measuring the same thing. How much does the spread of returns occur? And so you can see for treasury bills, the spread is really tight. It's really small. But for stocks, it's really spread out because there's lots of potential outcomes that might occur. Right? So that's what we say when we're thinking about what does this actually mean? Well, these two things help us characterize a stock. Okay, now we want to take a slight math digression, just a slight one, to talk about how we calculate averages, because there are two primary ways to calculate averages, and we want to be really careful when we talk about average to make sure that we are really communicating what we want to communicate. Okay, so I'm going to use a really stylized example here. So an example that's really unrealistic, but that is going to illustrate the two differences between something called the arithmetic mean or the arithmetic average, which is what I would call the simple average. That's your standard way to calculate an average. You add the numbers together, you divide by the number of observations, and something called the geometric average or geometric mean. Okay, so here's an example. We buy a stock for $100. The next year, the price falls to 50. The following year, it recovers back to exactly where it was. Right? The question is, what in this scenario, what is our average return? Okay, so in our standard arithmetic average, this is our simple average, our year one return is minus 50%. We lose half our money. Our year two return is plus 100% because we double our money to get back to where we started with. So if we take the average, the arithmetic or simple average, minus 50 plus 100 divided by 2 gives us a 25% average return. But my question for you is, does this make any sense? Did we actually generate a 25% return over those 2 years? No, we didn't make any money. We started at 100, we ended at 100. The fact that we lost half our money and then made it all back says, we generated a 25% average return, but that doesn't really make any sort of conceptual sense, because when we want to discuss return, when we want to communicate information by talking about the return, people expect that if I say I made 25% a year for 2 years, 25% on average over a 2-year period, that I ended up with more than what I started with, right? So we want to make sure that we are communicating the same thing. Now, the geometric mean will help us do that. The geometric return is a little different. I'll show you the formula. But the geometric return here, the geometric mean would say that there was a 0 return, right? So we want to ask ourselves, which one is a better measure in terms of communicating the information we want to communicate? Now in this example, it's obviously, or at least to me, obviously the geometric return. But in general, it depends on the planning period of your portfolio. So if we are talking about less than 15 years, right? So 15 observations of a return, it's typically better to use the arithmetic mean, the simple average. 20 to 40, we're going to calculate both and then split the difference. That's the return we're going to report. If we're looking at more than 40 years, we should probably only be looking at the geometric return. Okay, so let me show you another example. This is a more realistic, less stylized. Right, so here's 3 years of returns for a single stock: 5% in the first year, loses 3% in the second year, gains 12% in the third year. We want to communicate to, say, another potential investor, what is our average return year over year in this stock, right? So one way to do that is using the arithmetic or simple average. We add 5 and -3 and 12. We divide by 3. We've earned 4.67% on average over that 3-year period. Right? The other way to do it is using the geometric average. This is sometimes called a compound return per period. So we add the percent, the return, to 1 and multiply. So 1 plus 0.05 times 1 minus 0.03 times 1 plus 0.12, right? So 5%, losing 3%, gaining 12%. And then we raise that to the cube root. We raise that to an exponent of 1 divided by 3 because there's 3 observations, and we subtract 1, and that gives us 4.49% return. Right? So notice that when the example is not as stylized as our first one, meaning it's not as dramatic, the two return measures give a pretty close answer. Right? 4.67 for the arithmetic mean, 4.49 for the geometric mean. Typically, we tend to stick with the arithmetic mean. It gives us communicates what we want to communicate. Right? And I don't want to say gives us a better answer because that's misleading. It communicates more of what we want when we are talking about shorter time horizons, and geometric means communicate more of what we want when we're talking about longer time horizons. So if you're asking me to say what the average return is over a 100-year period, I should be using the geometric mean. If you're asking me about the average return over a 3-year period, I should be using the arithmetic mean.